Hello, I'm Benoît Marolo, Cloud Architect at the IBM Client Engineering Center in Montpellier, France. Welcome to this data governance and AI demonstration with IBM Cloud Pak for Data. In this demonstration, we're going to use the IBM Cloud Pak for Data, a tool that is essential in a data transformation and modernization project. And the business driver is to have this ability to innovate and reduce the time to market and leverage the business data that are stored in any cloud. This demonstration is about Cloud Pak for Data in action, and we're going to use three different components. So data virtualization to reduce data silos. We're going to classify, mask, and reinforce the data governance using Watson Knowledge Catalog. The third pillar is about creating more value and predictive functions with AI and machine learning, and we're going to use for that Watson Studio, Watson Machine Learning services from this Cloud Pak. So let's consider a fictive company, RetailOne. This organization needs to simplify the data access processes. The goal is to establish a data virtualization layer between all the dispersed data sources. In that case, ERP applications running on premises on AIX Oracle, business applications running in each store running on IBM I, DB2 and we're going to also have some data sources on the public cloud. The goal is really to simplify the data access without having to duplicate this data. And the ultimate objective of this demonstration is to show how you can easily build some advanced reporting tools with complex queries relying on multiple dispersed data sources. In that example, a simple virtual view that can help display the top 200 sales using multiple public and private cloud databases and data sources. And in our RetailOne example, we're going to use this virtual schema. And this virtual database will be used by our applications. Data will be then cached by this data virtualization to ensure the performance. And as RetailOne has several stores with different customer databases, data virtualization is able to detect that there are several similar customer tables that can be merged into a single virtual table. And this is what schema folding is about with data virtualization. In addition to the data virtualization service, we can also take benefit of the Watson Knowledge Catalog service to reinforce the data governance, dynamically establish some masking and business rules on the data. We can then create some rules to mask some credit card information or personal information as it is shown. So before applying the rule and after, this is what an application can see from this identified and classified information. So let's now proceed with a live demonstration. This demonstration is available on our IBM TechZone website. There will be three parts. First part is about data virtualization, creating a virtual schema, virtual database and views. And then create our first data catalog and data quality project, and with the ability to create to classify data and create some masking that can then be used by the data virtualization layer. And last but not least, we're going to use also collaborative tools that can be used with our data scientists and data citizen teams to then create some statistics and machine learning models for predictive functionalities using Watson Studio, Auto AI, and Watson Machine Learning. So first, let's connect to our IBM Cloud Pak for Data. And let's have a look to the different data sources already configured. In that particular case, RetailOne, as we said, has several stores and database for storing CRM information on IBM I. They have also a centralized CRM running on AIX Oracle in its data center, and some public cloud data sources. So as you can see, we can create different kinds of data sources on the IBM Cloud Pak for Data. It could be JDBC generic, it could be IBM-based data sources, or third-party data sources. We can also create local databases that will be deployed on the Red Hat OpenShift cluster like MongoDB database or DB2 warehouse or any other database server. So let's browse our data sources and create our first virtual tables and views. So on this particular screen, we have access to the data virtualization tool, and we can then virtualize several tables. You see the ordering or customer tables can then be um, joined or directly virtualized as a one-to-one relationship between physical and virtual tables um, without having to know where they reside. Data virtualization with an access to the physical table and cache some data for performance reasons. Here is the customers table, and this customers tables, as we said, is present in every store of RetailOne. So we may want to merge all these different, I would say, the customers tables in a single view or virtual table. In that case, we call this schema folding, where data virtualization will be able then to recognize that the structure of the table is similar and then merge the table into one single big virtual table, which could be really interesting to simplify again the data access process. And with a single table having the list of all our customers worldwide. The virtual table is now online, and we can then set up the caching policies, refresh rate, queries that will be cached. And here is the list of virtual tables and views in my retail virtual schema. The top sales view, for instance, lists all the sales worldwide, relying on multiple dispersed tables behind the scenes. And you see multiple tools to monitor this virtual database server, user management, so access management, connectivity information, so how to connect to my virtual database using, for instance, JDBC. And information concerning the underlying storage. And as we will see in the next part, this data virtualization service can integrate with Watson Knowledge Catalog to reinforce the data governance. And this is where you can activate this governance from data virtualization. And let's now focus on CP4D project. So this is my RetailOne project, including different connections and data assets. I've got also an auto AI predictive model already trained and deployed, notebooks, so Python scripts that I can write relying on data virtualization. I have also this access control, of course, on any project. A project is a collaborative tool. This is the different kinds of assets I can create: data, connectivity, notebooks, code, machine learning models, depending on the kind of project I created and the list of add-ons I installed on my Cloud Pack. And let's now have a look to the data in my project, my RetailOne project. As you can see, I can list my list of customers from my virtual table, and I can have a look to the different classes attached to each of my columns and business items created by a knowledge catalog automatically. And of course, I can then help the system pick the good class. In my case, I'm going to classify the phone number of each of my customers as personal information using a specific phone number class I've just created. So now this particular column is classified as phone number, and the goal as a data owner is to mask this data from the end users, reinforcing my data protection rules from a single pane of glass. Let's now have a look to my Jupyter notebook that I can share with all of my users. So it's collaborative, and I can then open this Jupyter notebook to play with the data, access the data, create reports and applications. So this is the connection to my database. Let's now connect to the retail virtual schema through data virtualization using JDBC. and perform a first filtering test. So as you can see, I can see in clear my phone number column that is not currently filtered. Let's create a first rule that will help me protect this data. To create a data protection rule, I'm just going to the rules menu, data protection rule, and I can then specify the name of this rule and the criteria on which I want to apply this rule. So for each column from the class phone number, so the class I've just created, and classify my phone column, please, Watson Knowledge Catalog engine mask me this data using an obfuscation or substitution mechanism. In that case, it's going to just display the XXXX instead of the phone number. I could have done this with credit card numbers, etc. The rule is now active, and automatically data virtualization will use this rule when querying the data from the application. And as you can see, I can query the data, and my phone number column is now protected and masked by data virtualization and knowledge catalog. I can also use the Jupyter Notebook to perform some advanced query to the data virtualization. So this was the first demonstration with data virtualization connected to on-premises data sources and cloud data sources, reinforcing a data protection rule using Watson Knowledge Catalog integrated with this virtualization layer. The last part of this demonstration is about creating a recommendation engine from the data we've just consolidated using this data virtualization and knowledge catalog layers. For this purpose, we used the Watson Machine Learning Service with Auto AI experiments that allow my data scientists to work in collaboration and create powerful machine learning models. So using this Watson Studio tools, you can easily create a regression or classification algorithm, in that case, recommendation engine, from customers' data sets we've just gathered using the data virtualization layers. And the goal here is to create a recommendation engine that can be used to help my customers based on the past sales from historical data and from my customer characteristics. In that case, age, gender, and marital status. And I can now deploy my newly created and trained model using a deployment. And I can then consume this model from any applications within any, protocols like REST API, for instance. And from this interface, I can now test my recommendation engine with a particular customer information. And in that case, as you can see, I can infer and test the model, and the golf equipment would be my next recommendation for this particular user. Thank you for watching this Cloud Pak for Data demonstration, and don't hesitate to reach out to us if any questions.